In this class, we are going to derive the cost minimization condition using the constraint optimization technique or the optimization technique. The cost minimization involves the question of how to produce a given output at the minimum total cost. The cost is minimized at the point of tangency of isoquant and isocost line. Here, the isoquant and isocost line determines the cost minimization condition. The equilibrium point is obtained at the point where the slope of isoquant is equal to the slope of isocost line. That is, at the point of tangency, the isoquants and isocost line the marginal product of the input is equal to the ratio of prices of the input. Here, the slope of isoquant is known as marginal rate of technical substitution that we have already explained, and the isoquant shows various combination of the inputs that can produce the same level of output. It is same as the indifference curve of the utility or the consumer's equilibrium condition or the utility maximization condition, and the isocost line shows the various input the price ratios of various inputs. Here, the equilibrium is obtained when marginal rate of technical substitution of labor for capital, this is the slope of isoquants, that equal to W by R. W by R is the prices of wage, prices of labor, or it is W is the wage price of the capital, that is MPL by MPK equal to W by R. That is W marginal rate of technical substitution of L for K equal to MPL by MPK, that equal to W by R. This is the cost minimization condition, and this can be graphically proved. Graphically shown as follows. The cost is minimized at the point E, where the slope of isoquant is equal to the slope of isocost line. It is the least cost combination of input. Here, the marginal rate of technical substitution of labor for capital equal to W by R, or marginal rate of technical substitution of labor for capital equal to MPL by MPK, that equal to W by R. This is the least cost combination of output. And the proof of these conditions are given here. The objective of the producer is minimization of cost of production subject to the constraints of the production function. Here, the objective function is minimization of cost. The constraint is given as in the form of the production function. The cost function is given as C equal to WL plus RK, and the production function is given as Q, a function of KL. That is, minimize this function C equal to WL plus RK subject to the production function Q, a function of KL. Then the constraint can be written as a function of KL minus Q equal to 0, and then multiply this with respect to lambda, that is lambda into a function of KL minus Q equal to 0. Then the new Lagrange function is can be written as Z. Here we have already L, therefore used another letter to describe the new function, that is Z is then equal to WL plus RK minus lambda, a function of KL minus Q. This is the new Lagrange function. The conditions are the same. Derive the partial derivatives and take the first order condition, derive the second order condition, and in order to derive the cost minimization conditions. Z equal to WL plus RK minus lambda, a function of KL minus Q. This is the objective function. This is the new Lagrange function, Z equal to WL plus RK plus lambda, a function of KL minus Q, and take the partial derivative of this function. The first order derivative is given as dou Z by dou L equal to W here, and derivative of WL equal to L equal to derivative of L equal to 1, therefore W plus, here it is 0, W plus, and this can be written as W plus lambda FL equal to 0, and likewise dou Z by dou K equal to R plus lambda FK equal to 0, dou Z by dou lambda equal to FLK FKL minus Q equal to 0. These are the three partial derivatives with respect to L, K and lambda. From equation 1, we can say that W plus lambda FL equal to 0 means W equal to lambda FL, or W by FL equal to minus lambda. And from equation 2, that is R plus lambda FK equal to 0, R equal to lambda FK, that is R by FK equal to minus lambda. Then W, that means that W by FL equal to R by FK both are equal to minus lambda, that is W by FL equal to R by FK, or we can cross multiply this, then we will get W by R equal to FL by, take this R to this side and FL to this side, W by R equal to FL by FK. Here W by FL equal to R by FK or W by R equal to FL by FK. Here FL by FK is nothing but the marginal product of labor divided by the marginal product of capital. This is the marginal rate of technical substitution of labor for capital. It is the slope of isoquant. And W by R is the ratio of input prices, that is slope of cost line. Therefore, the equilibrium of the cost minimization condition for the producer is given as the marginal product of labor by marginal product of capital equal to W by R, or where the slope of isoquant equal to the slope of isocost line. And at the equilibrium, the slope of isoquant is equal to the slope of isocost line, and the second order condition requires that the bounded, it is the minimization condition, therefore the bounded Asian matrix, determinant of the bounded Asian matrix must be less than 0. This is the second order condition.